so examples. So these are using the definition of the derivative. Find f prime of x. Okay, so I'm stating using the definition because you'll see that soon we won't have to use it anymore. We're going to use some techniques. Okay, so first, let's say f of x. So we did one last class, it was an easy one. I'm going to go now to x squared. Okay, so the first thing we do, so f of x is x2, f of x plus h is x plus h squared, and then f prime of x is limit h approaches 0, f of x plus h minus f of x over h. We know the definition. Limit h approaches 0, so f of x plus h is this guy here, minus f of x, which is x2, over h. Okay, so this is the limit we need to evaluate as h approaches 0. So limit h approaches 0, so I'm going to expand x plus h squared, x2 plus 2xh plus h2 minus x2, all this over h. Okay, no questions? Okay, so be careful, don't put x2 plus h2, right? I've seen this a lot. X plus h squared, you write x2 plus h2 and you forget the middle term. Okay, I've seen this a lot. x2 minus x2s are out. Limit h approaches 0, I could extract an h. 2x plus h over h. Let's say you plug in the h is 0 here and you are left with 2x. Okay, any questions? Okay, let me just illustrate what this means. Okay, so I'm going to draw the function y equals x2. Okay, I think we all know what it looks like. Okay, so it's a parabola. Okay, so this parabola is, so it goes through 0, 0, as we know, it goes through 1, 1. It goes through 2, 4. Then through minus 1, 1. And minus 2, 4. Okay, I'm just drawing a rough sketch about here. Okay, so my parabola would look like this. Okay, something like that. So what does what we just found mean? Well, it means that if if x is 1, okay, if x is 1, then there is a tangent here, and if x is 2, there is a tangent here, and the tangent at each place, at each point, has a certain slope. Okay, same thing at -1, at -2, for example. Okay, there's a tangent, I'm drawing it in green. There's a tangent here also. Okay, so what it tells me, if I want to find the slope of the tangent, I will do 2 times the x. So here it would be 2 times 2, which is 4. Here 2 times the x, which is 1, so 2. Here 2 times -1 is -2. And 2 times -2, this is -4. This is the slope. Okay, and at 0, of course, you see, it is flat because 2 times 0 is 0. That's what it means. Okay, so this function here, 2x, gives me the slope of the tangent at every point of the graph, depending on x.
But when it's on the left side, the slope isn't -2x.
-2. It's 2 times -1 is -2. The slope here is -2. The slope, right? Not the equation, nothing. The slope.
Exactly. So 2x is only for the part, the right part.
No, even for the left part. 2 times x. X is -1.
Okay.
Right? 2 times x, 2 times -1 is -2. If x is -2, 2 times -2 is -4. The slope is -4. Do you understand or no?
Yeah.
Any questions before I give you more to do? Okay, so this is the algebra, this I do it, and this is the interpretation on the graph. I'm not going to ask you to graph, okay, and then find the slopes. No, it's just, this is just to illustrate what it means, and it's like what you did in physics. This would represent the, if this was a position time graph, this would be the instantaneous velocity. That's what it would be. Okay, so the velocity, that's at what rate does the position change, basically, over time. Okay, so the rate of change. Yeah.
So I have a question. Why do you square the x plus h?
Why do I square it here?
Yeah, exactly.
Here?
Yeah.
Because, okay, because f of x is x2, right? F of x is x2, that's the function I have. So instead of plugging in x, if I plug in x plus h, then it would be x plus h power 2.
Ah, okay, okay, I understand.
Okay? If this was the f of w, you would have w power 2. Whatever there's an x, you replace, anytime there's an x, you replace it by x plus h. That's how it works. Okay, good?
All right. Perfect, thank you.
Okay, let's try a few more, okay? So number 2. So you're going to try this one. So let's say f of x is equal to 3x2 minus 4x plus 5. So f of x is 3x2 minus 4x plus 5. So f of x plus h. Okay, so this is the tricky part. Okay, so you have to replace every x by x plus h. So 3 times squared minus 4 times x plus 5. And so you replace the x here by x plus h and the x here by x plus h. That's how you do it. Okay, so f prime of x will be the limit as h approaches 0 of f of x plus h minus f of x over h, which is the limit as h approaches 0 of, and so I'm going to have a big fraction here. So f of x plus h is this whole big expression. So 3 times x plus h squared minus 4 times x plus h plus 5. This is f of x plus h minus f of x, which is 3x2 minus 4x plus 5. Okay, so don't forget the bracket because it's f of x, all of it, minus sorry, f of x plus h all of x minus f of x all of x. Okay, so now let's expand everything here. So I'm going to open it up right away. So I have 3x2 plus 6xh plus 3h2 minus 4x minus 4h plus 5, and then minus 3x2 plus 4x minus 5. I shouldn't forget to change the signs because there's a minus in front of the brackets. And all this over h. And now we could clean up things. So 3x2 minus 3x2 is out, minus 4x plus 4x plus 5 minus 5. Limit h approaches 0, and I'm going to extract an h from each of these three terms. H times, so 6x plus 3h minus 4 over h. Cross out the h's, and then plug in the h is 0. You're left with 6x minus 4, which is pretty much what you all wrote on the chat. Okay. Are there any questions before I go on to something a bit more difficult? Okay, I move on.
Yes.
Let's go. Number 3. Try this one now. Okay, so f of x is equal to 1 over x. F of x is 1 over x. F of x plus h is 1 over x plus h. Okay, and so f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h, which is the limit as h approaches 0 of 1 over x plus h minus 1 over x over h. Any questions until here? Anyone? Okay. At this point, I will have to find the common denominator on the numerator. So limit as h approaches 0. So what do I do here? I will multiply, right, like you did in high school. So you multiply the top by x here and the bottom by x. And here I will multiply by x plus h, top and bottom. So that the both fractions are over x times x plus h. Okay, we've seen this before, you've seen this for sure. So on the bottom I have h, and now on top, they're both over x times x plus h. So I'm gonna go like this, x times x plus h, and on the top, I have x minus, and on the right, I have x plus h. Okay, so now I have a fraction divided by a fraction. Limit h approaches 0. So the top fraction is what? X minus h over x times x plus h divided by h over 1, or just times 1 over h. Okay, that's how you divide fractions, right? X minus x is out. So I have limit h approaches 0 of, on top is negative h, sorry, and on the bottom I have h times x plus h. Cross out the h's, and then plug in the h equals 0, and you have negative 1 over x times x, which is x2. Okay, so I'd say about half of you guys got it from the answers I received on the chat. Questions? Okay, let's do 2 more. Okay, we're going to do 2 more, and the rest you're going to do it from the worksheet that I'm going to post. But the 2 essential ones, 2 more. Okay, I could take it out, change. Yeah.
Yes.
Okay, let's go. Number 4. So f of x is equal to the square root of x. F of x equals to square root of x. F of x plus h is square root of x plus h. F prime of x equals to the limit as h approaches 0 of x plus h minus f of x plus h minus f of x over h, which is limit h approaches 0 root x plus h minus root x over h. What do I do at this point? Anyone?
The conjugate.
Multiply by the conjugate, which is root x plus h plus root x, top and bottom. That is limit as h approaches 0. So root x plus h times root x plus h is x plus h and minus x. Okay, simplified it right away. H root x plus h minus root x. Cross all the h's by the x's. Limit as h approaches 0, h over h root x plus h plus root x. Cross this out. Plug in h is 0, it's 1 over root x plus root x, which is 2 root x. Any questions? Okay, let's do one last one.
Sorry, how is the bottom 2 square root of x?
Because if h is 0 here, I have root of x plus root of x. It's 2 times the square root of x.
Okay, perfect.
Okay. Okay. Last one, number 5. F of x is equal to 1 over square root of x. F of x is 1 over root x. F of x plus h is 1 over the square root of x plus h. F prime of x, limit as h approaches 0. F of x plus h minus f of x over h equals the limit h approaches 0. Here it goes over h, and now f of x plus h is this fraction here minus f of x. It's this fraction here. Okay, so far so good, right? So again, I'm going to find the common denominator on top. So I will multiply here by root x top and bottom, and here by root x plus h top and bottom. H approaches 0, so everything over h. And now the fraction on top is over root x times root x plus h. And now I have root x minus root x plus h. Okay, so just like in the last example, we have a fraction over a fraction. And so I will multiply by the reciprocal. So it's limit h approaches to 0. On top I have root x minus root x plus h. And on the bottom I have h times root x times root x plus 6. That's what I have. Okay, and at this point, I will multiply by the conjugate. Root x plus h, top and bottom. Okay. So on top, I will have x minus, in brackets, x plus h. And on the bottom, I have this whole thing here. H root x plus h, root x plus h. Okay. Limit h approaches 0. So on top, I have x minus h, and on the bottom, h root x plus h, root x plus h. Okay. Cross out the x's, and then eventually I will cross out the h's as well. And so I will have the limit h approaches 0, negative h over h root x plus h, root x plus h. Going to move up a bit. H's are out, and then I replace the h by 0 everywhere I see an h. I'm going to have root x times root x, which is x, and root x plus root x is 2 root x. And so we'll have negative 1, right? Negative 1 over, so x times 2 root x. So that's what I have. Okay. That's my answer. Okay. No questions? So at this point, you understand, I think we did 5 examples. Some of them were a bit more difficult. You should be able to do all the worksheet that I'm going to post on finding derivatives, okay? You can do everything besides for the one involving trig functions, because this is a bit more tricky, okay? I'm going to show you eventually. Okay, let's go. So let's move on. So differentiation techniques. Okay. So what does differentiation mean? Okay, so differentiation is equal to finding the derivative. That's what it means. Okay, so now I'm going to show you techniques to find the derivative so that I could avoid going through all this pain of this steps, the long steps that we did. Like it took us here, 2 seconds, it took us a page to do this, okay, a full page, okay, to find the derivative of 1 over root x, okay, to get to this here. So I want to show you a technique, a few techniques, and you'll be able to do this in one line. So the first, there's a few rules that you need to know. First one is what we call the linear properties of the derivative. Okay? So what does this mean? Two things. First of all, if you have a function that is equal to a sum of two functions, okay? So you have a sum of two functions, then if you want to find the derivative of this function, well, you could just do the derivative of each one. This plus the derivative of v, and that will give you the whole derivative. So you're allowed to do the whole derivative for each one and add them. Okay, same thing if this was a minus. Same thing. Okay, that's the first property, the first linear property. The second one is that if f of x is a constant times a function, okay, then if I want to find the derivative of this, well, I could just do the constant times the derivative of the function. This is the first big rule for derivatives, and if you notice, even the limit has the same properties, right? If you want to find the limit of the sum of two functions, you could do the limit of the first plus the limit of the second, and if you have a number in front of a function, you could pull it out of the limits. Okay, so it's the same property, which makes sense since actually the derivative is nothing other than a limit. It's a limit as well. Okay, so that's the first property. We're going to do examples for you to feel how this works in a minute. Let me just show you the second rule, which is very important, okay, which is the power rule. Okay, the power rule is as follows. If f of x is x to the power of anything, okay, then the derivative is, so you put the exponent in front, n times x, and you minus 1 from the exponent, n minus 1. That's how you find the derivative of x to the power of something. Okay, so what I'm going to do is I'm going to give you a few examples on applying these rules, okay? And you'll see that's much, much faster than using definition. And then I will prove the first property, because we have to prove everything in this course. I will prove it. And this one, the power rule, I will prove later on in the course, okay? When we're going to do implicit differentiation, it's going to be much, much faster to prove. Well, if I do it now, it's much, much longer. And I need to show you something that you don't know to prove it, okay? So might as well, we'll wait for later on in the course to prove the second rule. Okay, the other rules, there's 3 more rules after that. The quotient rule, the product rule, the quotient rule, and the chain rule. 3 more rules after that. And we're all going to prove, besides for this one, which we're going to prove later. Okay, so let's do a few examples first. So I'm going to leave this in front so you could see them. So examples. Find f prime of x. So first, very easy one, f of x equals to x cubed. Okay, so right away tell me what's going to be f prime. What does my rule tell me? Tell me, so x power 3, so you put the 3 in front, so it's 3 times x to the power of, well, 3 minus 2, 3 minus 1 is 2. Get it? Easy? Okay, another one. F of x equals to x squared. What's it going to be? What is it? Anyone?
2x.
2x, right? 2 times x power 1, so 2x. Okay, so we did it using the definition. It was our second example, or our first example today. And we found 2x, but it just took us a lot of time there. And you see here, we do it in 1 second using the rule. Okay. Number 3. F of x equals to x. Number 4. f of x equals to 5. What is it? Number 3, what is it?
1.
1, perfect, because it's 1 times x to the 0, which is just 1. And 5, what's the derivative of 5?
0.
0, exactly, because 5 is the same thing as 5 times x power 0. And if you bring the 0 down, you'll get 0. So this is 0, which makes sense because this is a function that is constant, right? F of x equals 5 is a constant function, straight line, flat. And you know that a horizontal line has a slope of 0. That's why the slope is 0, the derivative is 0 for all x. Okay, let's do a few more. Number 5. So f of x is equal to square root of x. Number 6, f of x is 1 over x. Okay, so f of x equals square root of x. So the square root of x is x power what? It's x power half. So f prime, so I put the half in front, times x to the power of a half minus 1, which is negative 1/2. And which is what you found using the definition a few examples ago. Okay, it's good, you get it? 1 over x is,
Sir, can you explain the number 5 again? Sorry.
sure. So you understand that the square root of x is x power half? Is okay?
Yes.
Okay, now I'm going to use this rule here. So x power half, the derivative will be a half times x to the power of a half minus 1, which is minus half.
Oh, okay.
I'm
Thank
just
you.
applying the rule. Okay? Same thing here. So 1 over x, I'm writing it in exponential form, so x power minus 1, so that I could use the power rule. So what's it going to be? Minus 1 times x to the power of minus 1, which is minus 2. Any questions?
Yeah, could you explain number 4 again?
Number 4?
Yeah.
This one? Sure. Okay, so just for you to know, for this one here, so f of x is equal to 5, which is equal to 5 times x power 0, right? Because x power 0 is 1. And then I'm going to do the derivative. 5 times, so the derivative of x power 0 is 0 times x power 0 minus 1. That's my rule. That's it. So it's 5 times 0 times x to the minus 1. So that's 0. This is actually f prime of x. Is it clear?
Yeah, thank you.
Okay, so let me give you something a bit harder now. Okay. Yeah,
Can we leave it in negative exponents?
you can, like I did here. Sure.
Yeah.
Of course. Or if you want, you could do it like you did in the when you did it using definition. So this is 1 over 2 root x, and this is negative 1 over x2. Okay, I would accept both ways. Okay? Usually we write it this way, right, without negative exponents, but it's up to you. Okay, so you could compare it with the answers we got using the definition. You'll see that they're the same. Okay, could I continue?
Yes, thank you.
Okay, let's go. Any questions? Anybody else? Anybody want me to repeat? Okay. Let's keep going. So we did those question, example 1 to example 6. So let's do now example 7. So f of x is equal to, so 7x3, then 8. F of x equals to 2x minus 3 over x2 plus 4 over the square root, cube root of x. Okay, 9. F of x equals to the 5th root of x2 minus 4 times the 4th root of x cubed minus pi to the power of 8. And the last one, 10. F of x is equal to x3 minus 1 over root x minus 8. First one, what did you get? First one is easy. Anybody?
21x squared.
21x2, very good. Second, okay, so the second one, before starting to find the derivative, I'm going to write everything in exponential form. Okay, so 2x minus 3 times x to the minus 2 plus 4 times x to the minus 1/3. Okay, and now I could derive it easily using my power rule. So f prime is going to be 2 minus, so 3 times minus 2 is minus 6, so minus minus 6, so plus 6. X to the minus 2 minus 1 is minus 3. And then minus 4/3. X to the 1 minus a third minus 1 is minus 4/3. This is what I get. Okay, same thing here. I will write everything in exponential form. So x power 2/5 minus 4 times x power 3/4 minus pi power 8. Okay, so f prime of x. So I put the 2/5 in front. X power 2/5 minus 1 is minus 3/5. Then minus 4 times 3/4 is minus 3 times x power 3/4 minus 1 is minus 1/4. And then minus, what is this? 8 times pi power 7. Is this okay? Does anybody have a question with what I wrote? Yeah?
What is the 2/5 become? Never mind. My bad.
Okay. Anybody else?
Sir, can you explain 8 again?
Number 8?
Yeah.
So the first thing I did here is I rewrote the expression with in exponential form. So 2x here is minus, then 3. This is x to the power of minus 2. right? This you know, you okay with this?
Yeah.
Okay, plus 4, and this is x to the power of a third, which is downstairs. So I send it up, it becomes x to the minus 1/3. So this is okay?
Yes.
Yeah. Okay, so now at this point I just derive. So here I put the 1 in front, times x to the 0, so it's just 2. Then minus 3 times minus 2, it becomes plus 6. And x power minus 2 minus 1 is minus 3. Okay,
Can you
okay?
repeat that?
This one here.
Yeah.
Okay, so what I did, I put the minus 2 in front. Right? That's my rule, right? My rule tells me to
Yeah.
put 2 in front. So minus 2 times minus 3 is plus 6.
Yes.
Okay, and then x power minus 2, you minus 1 from that. So minus 2 minus 1 is minus 3.
Oh, yeah. Okay.
Okay, and same thing here. So negative 1/3 comes in front. So 4 times minus a third is minus 4/3. Here it is. X to the power of, so minus 1/3 minus 1 is minus 4/3.
Okay. Thank you.
Good. Yeah. Any other questions?
Yes, for question 9,
Yeah.
for minus pi to the 8th power, why is it not 0? Because it's just a number.
Oh,
there's no
very
x.
good. Very good. So that's the question I wanted to hear. Okay. So this, you're absolutely right. This is 0. Okay. That's why I wrote it in pencil. Okay. Because I'm going to erase it. But this, don't get fooled by pi power 8. Don't think that this you're going to use the power rule here, because this is a number. Pi power 8 is, I don't know, 3.14 power 8. That's a number. So when you do the derivative of a number, you get 0. So this, you're right. This disappears. Okay. So that's a trick that teachers use a lot. Okay. We put pi power 8, e power 8, or e power whatever. Okay. We put a number in exponential form, and we trick you, we fool you into thinking that it's a variable, but it's not. Okay, so this is good. The answer is like this. There's no pi at the end. It disappears. Okay, last one. So same idea.
Sir,
Yeah,
but why does it disappear?
because it's a number. It's a number. A number, the derivative of a number, if you, 2 seconds, I come back here. The derivative of 5 is 0.
Okay, thank you.
Okay. So whether it's 5 or pi power 8 or 20 million, simply. Okay, so let me write this into exponential form. X3 minus x to the power of negative 1/2 and minus 8. And now it's easy. F prime is, so 3x2 minus 1 times minus 1/2 is plus 1/2. X to the minus 1/2 minus 1 is minus 3/2. And minus 8, the derivative of 8 is 0. So that's it. It stops like this. Okay, any questions? Okay, no more questions? Okay, I have a question on the chat, but you're talking about pi power 8, but I don't know if I answered you while I answered the other one, or you wrote it after, I don't know. Okay, it's all good. Okay, good. So this is how it works. Okay, this is we applied the power rule and the linear properties, right? Of doing the derivative of each piece, or the derivative, we pull out a number times the derivative of the inside. So we pretty much practiced the first 2 rules. So now what I'm going to do is I want to prove the first rule. Okay, so we have about 10 minutes left. Let me see if I could prove it. Okay, so proof. So first thing I want to prove is that if f of x is equal to u of x plus v of x, then, I don't know, I want to prove f prime of x is equal to u prime of x plus v prime of x. Okay, that's the first thing that I want to prove. Okay, which is the first of the two linear properties. All right, so let's try it. So f of x is equal to u of x plus v of x. Then f of x plus h. What's f of x plus h? Anybody?
U of x plus h plus v of x plus h.
Very nice. So it's u of x plus h plus v of x plus h. Okay, so now let's use the definition. So f prime of x will be equal to the limit as h approaches 0 of f of x plus h minus f of x over h. So every time I want to prove something with derivatives, we're going to go back, right? We refer back to the definition, okay? So equals to the limit as h approaches 0. So here we go. F of x plus h is so u of x plus h plus v of x plus h minus, and then f of x, which is u of x plus v of x. And all this over h. No questions? Okay. So what I'm going to do now is I'm going to open everything out on top and put the u's together and the v's together. Limit h approaches 0, so I have u x plus h minus u of x plus v of x plus h minus v of x. All this over h. Okay, nothing too crazy. So now I could separate this into two fractions. So I'm going to go like this. Limit h approaches 0. So the first fraction I will write u x plus h minus u of x over h plus the second fraction v x plus h minus v of x over h. Okay, so the limit of all this. Okay, so you see I did not change anything because it's the same denominator. And now I'm going to use the fact that the limit could go anywhere it wants. I'm going to put the limit here and limit there. And I will get limit h approaches 0 of u x plus h minus u of x over h plus limit h approaches 0 v of x plus h minus v of x over h. Questions? Do you recognize this? What is this here? U of x plus h minus u of x over h, limit as h approaches 0. Well, that actually is u prime of x. Right? We know this. That's the definition of the derivative of for u of x. Plus, and this is also v prime. That's it. Proven, done. We showed what we needed to show, put a little box to show that the proof is over, just like they do in the books. Any questions?
Sir, for example, in an exam like a midterm or final, will we have to prove like theorems like this?
Yeah. You won't have this one probably. I'll give you something else. I'm going to give you my old test, and you will see that there are proofs sometimes. Okay, so you really have to understand everything. Okay, so try not to memorize and try just to understand it. It's much easier this way. Okay, questions? Okay, no question. I will.
Sir, what was the last step?
This one here.
The one right before, yeah, how'd you get there?
How do I get here?
No, how'd you get from there to the last step?
From
yeah.
here to the last?
Yeah, exactly. How'd you get there?
Okay, because this, if you look carefully, this is the definition of u prime. If I wanted to find what u prime of x is, it'll be limit h approaches 0, u of x plus h minus u of x over h. That's what u prime is.
Okay. Yeah. All right, I got it.
Same thing for v. Okay. I'm going to take 5 minutes quickly and show you the second part of the linear properties, and then I'll let you go. Okay. One's much easier and faster to do. Okay. So another proof that if f of x is equal to k times u of x, then I want to show that f prime of x is k times u prime of x. Okay, so again, f of x is k times u of x, so f of x plus h is k times u of x plus h. So f prime of x is equal to limit h approaches 0, f of x plus h minus f of x over h, which is the limit h approaches 0. So f of x plus h is k times u of x plus h minus f of x, which is k times u of x, all this over h. Okay, easy. And as you know from the limit, I could extract the constant. So I'm going to extract the k. K is going to come outside. Okay, I could pull it out here and then pull it out of the limit. So it's k times limit h approaches 0, u of x plus h minus u of x over h. And again, we recognize, just like the last proof, that this is u prime. And so this is k times u prime of x dot. We proved it. Okay, it's a few lines. It's a very easy proof, this one.